Once again, full disclosure, I didn't buy this BNC Model 865 microwave/RF signal generator. It was sent to me free of charge by the Berkeley Nucleonics Corporation for review. This is already the second part of the review where I will remotely control the unit using the provided software and my trusty notebook. In the interest of brevity, I will not repeat each and everything I've already done in the first part where I operated the unit using the touchscreen interface and the rotary knob. So if you haven't seen part 1, card here and link in the description. So let's dive in. To remote control the unit, you need, of course, some kind of interfaces, and at the back you find a GPIB connector, which is optional, and standard a USB and LAN connector. So let's plug in a LAN connector and a USB connector. On the unit itself, you can configure within the configuration menu and the communication submenu your network address and your GPIB address. GPIB address, of course, being something between 1 and 31. 0 being the GPIB controller itself. Anyway, we won't do anything with the GPIB interface. It's an option, as I mentioned, and I don't have a GPIB controller. For configuring the network address, you have 3 options. You can either use auto, which is simply a DHCP with a 0 fallback, so some fixed address, or you can use DHCP only if that is provided in your lab's network, or you can do a manual configuration, which I will do because it has the most options. So IP address is 192.168.1.170. This is almost good, so let's turn that up to 234. That should be available in my local area network. Gateway address is already correct and subnet mask is also correct. So let's apply these settings. Almost forgot to mention it. In the DISP submenu of the configuration menu, you can lock out local operation of the device by choosing remote only. We will try that out later when we have actually remote control. So let's install the software live and uncut. It comes as an MSI file. Welcome to the signal generator setup wizard. Next, I accept the license terms. Next, installing to program files x86. Next, install. Okay, it obviously needs a third-party component, IVI shared. Okay. And now it's Visa shared components 1.6. Okay, and then I get a zip file. Do that. And it has successfully unzipped something. And now we are installing the Visa shared components. Yes. I accept the license. Yes. Next. Next. And we are finished. And we can launch signal generator GUI v2.119. And there it is. That was easy. Unfortunately, it says there is an update available. So let's update it. Okay, the same thing as before. Don't change anything. Install. Okay, it wants a reboot after that. That's okay. Okay. Launch signal generator GUI. Maybe we should restart. I'll restart the computer. I rebooted my PC and restarted the signal generator GUI. There's of course an entry in the Windows Start menu and an icon on the desktop. It immediately started to scan for instruments and it immediately found my model 865-40 on the IP address that I configured. And now we can connect to that device. There we are. And we could start remote controlling it. But before we do that, let's disconnect it. And I pull the network cable because it's a little bit inconvenient. It dangles from the ceiling and I want to get rid of it. And instead use the USB port and I plug that in. And yeah, there it is. Instantly. Our model 865 as USB and then some idea. Other options here for connecting. Of course, you can connect GPIB devices. Which makes no sense for me. Neither my notebook nor my model 865 has GPIB built in. As I mentioned before in the other review, there's a GPIB option for the 865. You can start the scan again. It's scanning here in the background my whole network. But you can also enter directly an IP address here. And I surmise you can then also connect to devices in another subnet. So basically throughout the whole internet, which might come in quite handy nowadays when you're working from home and you want to access your signal generator at work. Anyway, a normal internet port is 10, but you can also define a custom port for the communication. That all said, let's have a look at the display and the oscilloscope at the same time while we do all that remote stuff and yeah, go through the menus and see what we can do. Before we actually play with the function generator functionality itself via remote control, I wanted to show you the rest of the menus here. For that reason, I connected once more, or will connect right now, once more via the network. So I can probably show you the remote control network configuration menu. And please note, as I connected via the network, the display, let me lighten it up here. Oh, sorry. The display here in the status area now shows the text LAN remote control. It's a little bit small here, but you get the idea. So in the network configuration menu, you can do all the things you can also do remotely on the unit, directly on the unit. And yeah, we already have done that at the start of the video, configuring a network address. Please note, if you change the network address here and say save, your connection of course will break and you have to rescan for the unit and connect again. Same holds true for the GPIB address menu, where you can simply change remotely the GPIB address of the unit. If you do that, your connection breaks, you have to scan again, you have to reconnect. Memory control. We also have this in the unit. We saw that in part 1 of the review. I won't go into the details here, but you know you can save up to 10 settings, yeah, in the memory of the unit and then recall them. 0 being, yeah, the power up settings. And yeah, we saw that in part 1. It's exactly the same. And you can give the whole thing an individual device name if you want to. Okay, but that's for these maintenance and utility stuff here. Now let's really start with a remote control. The continuous wave menu, looks almost the same as on the generator. At least you have frequency, power, phase, and RF on off. And let's switch the RF on so you can see something on the oscilloscope. Anyway, you can enter your frequency, like in numericals, like 250 megahertz, a bit much for my scope, but okay. So let's do 200 megahertz. You can, of course, use the up and down keys to do that too. You have the power setting, like directly on the unit, where we can enter, like 10 dBs or minus 10 dB, or you can use the arrows up and down. That works also nice. Note one little difference here. You don't have this low AM noise button on the unit. If I activate that here, you get a third digit, after your decimal points for the dBms. So you can really fine-tune your output power. That comes with some caveats. For example, when you do sweeps through the frequency or the power, you need to put in some delays so it can stabilize the output power. Anyway, we can change the phase of the output signal relative to the reference signal, frequency reference signal that is used. Of course, you can't see that here. But for all these technical details, how the function generator actually works, please view the part 1 of that review first. Anyway, let's go here back to 360, that's 0 basically, and here back to 0 dBm, and continue with the sweep menu. Before that, let's deactivate the low AM noise option again, because I couldn't show you its effects on my scope even if I wanted to. And start with the frequency sweep. The left-hand side here of the screen you find directly in the sweep menu on the unit under menu 1. And let's say we want to do a sweep from 1 megahertz to a whopping 100 megahertz. And of course, you can use the arrow keys too. Side notes, if you enter the digits here, you need to the tab key to move from digit to digit. That's a little bit different than here on the continuous wave screen, where it automatically jumped to the next digit. A little inconsistency. The right-hand side you find here on the unit under the menu 2. And let's start with the similarities. Of course, you can define how many repetitions you want in the sweep and if it should repeat indefinite. That's here. For all this, please refer to part 1. It was explained there in detail. You can define the number of points. 3, is perfectly okay. You have the dwell time and the off time between sweep steps, exactly like here. And let's say we want to do 1000 milliseconds, so a full second. And the off time, there you have the first additional option here in the software that's not available on the unit itself, and that's auto. So if you click auto, it calculates the required off time between sweep steps automatically. Maybe you remember, I'm not sure if I mentioned it, but the total time to execute a sweep step, there is a minimum time requirement for that. You can look that up in the manual. And the auto function will, if you go to very short dwell times, automatically add enough off time so you are within that limit. Then we have sweep mode, linear, logarithmic, and randomization that you don't find on the unit. Linear is simple, yeah, when we start at 1 megahertz and go to 100 megahertz in 3 points, so it will add a sweep step of 50 megahertz in between. So let's just run that here, and I have to adjust the time scale on the scope, I guess. A little bit more, a little bit more. Now, 1, 50, 100. 1, 50, 100. Yeah, normal sweep, just, yeah, with 3 points. If we do a logarithmic sweep, it will insert the steps in between the start and the stop frequency in a logarithmic fashion. So in our 3-point example, that would be 1 megahertz, 50-ish megahertz, and 100 megahertz. So have a look at that. 1, 50, 100. 1, 50, 100. Okay, now randomization. Let's take a few, also not available on the unit. Let's take a few more points. Let's say 10 and go down with the dwell time to 500 milliseconds and say linear and random. Or let's first do it as a linear. So we're stepping through our frequencies. Oh, I was on random, sorry. So we're stepping through our frequencies in a linear fashion as we expected. If we choose random, and that works for log of course too, we're jumping through frequencies in the sweep randomly. Now, 2 remarks here. First, that random sequence is selected only at the start of a sweep. So if I click here again and activate the sweep, we see a little bit different random sequence. But that random sequence is repeated again and again and again. It doesn't change. Second remark, the random function does not work like a lottery. So it's not like you have a big bowl with your sweep steps in it and it draws. Oh, sorry. Camera shake. And it draws from it so that each sweep step is executed exactly once, but in a random order. It's more like it's throwing a dice to select sweep steps. In our case, 10 times. That means a single sweep step can occur several times in that random sequence, but other sweep steps might not occur in that random sequence at all. Let's continue with the power sweep. So the power sweep, and let's switch over on the unit also to the power sweep. Submenu 1. Oh, we're already there. Basically the same for the left hand side, only you have now in the software and in the unit a start and a stop power, and I already prepared an example for you to demonstrate the RF blank until trigger option, which I skipped here in the frequency sweep. Anyway, sweep mode, there's only a linear sweep mode, of course, no logarithmic sweep mode, because DBM is already a logarithmic unit. Repetitions exactly the same. Note I configured an external trigger now, so I'm no longer running infinite, but trigger my sweep externally. That's the reddish signal here that occurs every 500 milliseconds. You can't see the source really, it's above here off screen signal generator. Again, we've done that in part 2. enough times. 3 points, yeah, let's stay with the dwell time 50 milliseconds and off time also 50 milliseconds. And if I activate that now, you see on the scope exactly what you expected. So minus 20 dBs, minus 10 dBs and 0 dBs. And please note, yeah, these are now between triggers 500 milliseconds. And I went down with the frequency to 100 kilohertz. Now, if I deactivate that function, and again, this option, yeah, here, menu 2, they are all there, but for the sweep mode, the ALC and this RF blank until trigger and auto, of course. If I activate the sweep now, you see on the scope that after the sweep is officially finished, it just stays with the output on the last sweep step. So our 0 dB output power until the next trigger occurs, and then the next sweep starts. While, yeah, the name says is radio frequency blank until trigger. If we activate that, after the last sweep step, the high frequency output of the generator is switched off. Side note, you probably have noticed that there is no random option here visible in the user interface. However, if I activate random over here and go back to power sweep and start the sweep again, and stop it and start it again. Okay, that's the same. Yeah, that's just probability. Start it again. That's different now. You see, it is able to execute random sequences also for the power sweep. But for some reason, yeah, the menu entry here is missing. Again, a slight inconsistency in the user interface. Yeah, next stop, list sweeps. The list sweep, it's the most powerful sweep of them all because you can sweep at the same time over frequency and power. Please note, this functionality is exclusive to the software GUI and is not available at all on the unit. So to set up a list, we have to go to the list memory. There's nothing there at the moment. And let's say we do a sweep from 1 megahertz and minus 20 dB, dwell time 1 second, delay 0 seconds. 2 megahertz, minus 10 dB, just the same, and 3 megahertz, 0 dB, the same. Now we have to save that under a name, and then we upload that at the current list we want to execute and say OK. You can also, send the list to the RAM of the unit with that button, but if you click OK, that already happens. And now, please note, I resetted all the trigger stuff and so on on the unit, and we are just now outputting a 1 megahertz sine wave at minus 0 dB. Okay, 0 dB. So let's execute and have a look. And there it is. 1 megahertz minus 20, 2 megahertz minus 10, and 10 megahertz 0 dB. Great. You have, of course, the ALC mode available here, and if you use a trigger, that RF blank until trigger option. Repetitions, all the same like for the other sweeps. But you could now say, okay, I want, for example, if I first go to continuous wave and reset the unit to 0 dB, and then return to my list sweep and say, okay, I just want to sweep the power from my list, then it does exactly that. And the same works, of course, if you reset the whole thing. The whole thing works, of course, when you do just a frequency sweep, and then it stays on the last power setting. Yeah, perfect. And of course, you can do the list from top to bottom or from bottom to top. Yeah, we do it exactly the other way around. Or you can have a random execution of the list. Yeah, my lengthy explanation of what random means in that case, you hopefully remember that, because I won't go into the details again. So here he is jumping between 2 points, and if we stop and start again, the same 2 points, a little bit different. Stop and start again. Yeah, different points. Okay. That's it for the list sweep. Very simple to set up, but also very powerful. The reference menu holds absolutely no surprises. Surprise. If we go on the unit onto the reference menu, you see basically the same options. It's only a little bit different structured. So please, for the technical details, again, refer to part 1 of that review. We have an enable reference output. That's a BNC at the back of the unit, and it's either disabled or it's 100 megahertz. You have, you saw it switch here in real time too. We can enable an external reference either at 10 megahertz or at 100 megahertz. The user interface is a wee bit different here than on the unit, but no problem to understand it. And let's go back to the internal reference, because I haven't connected an external reference. So, next, triggers. The trigger menu. We already spent quite some time in the first part of the review on that one, so please refer to that part for technical details. I try not to repeat anything we've already done back then. Anyway, let's change here on the unit also to the trigger unit menu so we can see what's happening. Let's start with the trigger source. We already had that here, but what we couldn't test back then without the software is the bus triggering. And to demonstrate that, we'll use our list sweep that we've set up. 1 repetition, not infinite, so really just 1 repetition. And let's activate that. And you see nothing is happening until I click that button. That is, I trigger the unit via the bus. And if I click it, then our sweep, 1, 2, 3 steps, goes through, it stops. Again, 1, 2, 3 steps. External trigger, we did that at announcers in the first part, so I won't repeat that. What you noticed here, the key option is missing here in the software. And if we activate the key option, Okay, sweep is over. We can actually use on the unit this trigger thing here to activate, to send a trigger signal. That's one of the slight changes I mentioned before. Just as a matter of course, I updated the firmware, and I criticized in the first part that this is not working on that unit, and according to the manuals, it's only for the desktop model. And this, what I have here, is the compact model. But they fixed it meanwhile, obviously. Anyways, let's go back to our bus trigger, here, the LAN trigger, and try single triggering our sweep. It's the same like for the external triggers, okay? So we trigger here, stop, I click again, nothing happens because I have first to rearm the unit. That's the trigger init mode, by the way. And now that I rearmed the unit, I can trigger again. So it accepts only one trigger signal until you rearm the unit. But again, it was the same like with the external triggers. Trigger edge, rising, falling, positive first, negative first on both falling and rising edge. Does not make sense here with a button in the software. Yeah, we did that with the external triggers. Trigger parameter, also the same here. Normal, point, gated is here. Trigger type normal, trigger type point, trigger type gated. We already executed the complete list. You can also execute a single entry. For the trigger parameters, you have to click apply. Think about it. So every time I click, one step of the sweep is executed. And then we are at the end of the sweep because we repeated only once. So I had to go here to infinite. So I can now continuously trigger to single steps of the sweep. So 1, 2, 3, 1, 2, 3, and so forth. What else? Delay trigger by. That's an option you don't have on the unit itself. If I enter here, for example, 1, 2, 3, 1, 2, 3, 1 million microseconds, so 1 second, and I click now here on trigger, I have to wait a second. So click, wait, step. Click, wait, step. Of course, you won't, it's a microsecond. So its real purpose is to give you the ability to synchronize your trigger signal between different devices. Yeah, one device might react a little bit faster to a trigger, like, the signal generator. Others are a little bit slower in reacting to a trigger signal. And by using that delay trigger, you can synchronize different units in your lab. Anything else? Gated. Oh, I think I forgot to demonstrate that in the first part. So let me change the setup a little bit, and we just do that. So, trigger parameter gated. For that to work, we need an external trigger, of course. And I'm feeding in here an external trigger into the unit from my off-screen signal generator, which is 0.2 Hertz. It's just going on and off. And if we now use the gated trigger option and apply, then my sweep is only executed while the trigger is high. Yeah, you don't need any trigger signals during the sweep or to initiate the sweep. The sweep is simply executed while the trigger is high, and it stops executing as soon as the trigger goes low. That's gated. We already talked about a trigger edge here, but I wanted to point out that the last two options, trigger on both edges, positive first or negative first, are not available on the unit itself. Now let's talk about trigger continuous wave. For that, let's reset everything here and turn off the sweep and turn off here on the scope our external trigger signal, because we don't need it anymore. And I activate that use trigger to set frequency option. And then we go to our continuous wave menu. And if I now, please watch the scope, increase the frequency, nothing happens unless I click here on apply frequency. And then the frequency changes. That might be quite useful, if I'm fumbling around here with something 4.6589 megahertz, and I don't want, while I do that, the output of the generator to jump all over the place. So let's return here to the trigger menu and have a look at the last two areas here, trigger output and trigger output polarity. You find these on the unit in the trigger out screen. And I've shown you the trigger outputs in the first part, so I won't do anything with the scope right now. Anyway, trigger output polarity, that's simple. Inverted or not inverted, and you can see it's synchronized with the unit. Output polarity, normal and inverted. Trigger output is a little bit different structured than here on the unit. You have your pulse video, which is gated here, and then you have your different trigger output options, normal, point, and RF signal valid. So normal, point, and RF signal valid. So a little bit different structure than between the two different user interfaces. Anyway, let's continue with the low frequency out. The low frequency output menu. And I reconfigured the scope to show the trigger output BNC on the back of the unit here, where you get the low frequency output too. And on the unit, you don't have a whole menu tab for that low frequency stuff, but you have here this low frequency generator option. And interestingly, that gave you a fixed 400 Hertz sine wave here on the output in the previous firmware version. But now it seems they enhanced that tremendously, because now I have here a lot more options which are mirrored here in the menu. So our low frequency generator, and interestingly I have here these menu options too, so trigger output, pulse video, and that's synchronized and doing about the same things as here the trigger output. So I don't know. Anyway, you have a low frequency output here, and as I said in the first part, I just shown you that 400 Hertz sine wave, but you can switch between sine, triangle wave, or a 5 volt peak-to-peak square wave. And not only that, you can change the amplitude 2.5 volts being the maximum. Let's go back to 1 volt. And you can change the frequency up to, let's see how much we can turn up the frequency here. So 1 megahertz, 2 megahertz, 3 megahertz. Oh yeah, it's getting a bit noisy here. Above 2 megahertz, 4 and 5. No, it's not working. So there should be a limit here, but it's fine. Yeah, until 1 megahertz. 1 megahertz is quite nice waveform here on the scope. So it has a small low frequency generator built in. You would normally use that standalone or buy that unit just for this little low frequency generator that is built in. However, you can of course use that if you have the modulation option for the thing. Then you can use the low frequency generator to modulate your gigahertz sine wave, which is nice to have everything in one place. Okay, so you don't need an external modulation source. You can do everything within one box. Okay, I guess that's it. To wrap things up, the software installs without a hitch. It has a built-in auto update, which is a nice touch. It connects to the signal generator via local area network or USB cable without any problems. That's also very good. And I have no doubt you can also connect via GPIB without experiencing any hiccups. The user interface itself is old style, which is not necessarily a bad thing, at least in my book. Of course, that's subjective, but I don't like these newfangled user interfaces with the broad ribbons on the top and the scroll bars that you don't notice until you accidentally move the mouse on them. So yeah, I like it. It's clearly structured and for the most part follows the user interface on the unit itself. There are some, we saw it especially at the end with the low frequency generator and trigger stuff, some subtle differences. But basically, if you can work the unit, you can work the graphical user interface on your PC and vice versa. The software is not perfect. We saw there are some slight inconsistencies here and there. A random button in a sweep missing in one screen and it was available in another. But not really something I would call a bug. I mean, the functions that you get here in the graphical user interface, they work. Which brings us to the elephant in the room. You have a lot more options here on the PC to work the unit than on the interface on the unit itself. I can understand where the engineers at Berkeley Nucleonics are coming from. It's like the difference of having your Outlook email program on your PC and your Outlook email on your iPhone or Android. You don't expect the app on your phone to have the same functionality as, the big software on your PC. However, I think, and that's a constructive criticism, that you can still, add more functions here to that user interface. And as we have seen, Berkeley Nucleonics has done that from one firmware release to the other. The low frequency options that were really sparse, that is not existent in the previous firmware, they have been blown up to the same amount of functionality as in the PC software. And we already, sorry, screensaver, we already talked about the hardware capabilities in the wrap-up of the first part. With the software, you can do even more. So I won't repeat that. I mean, it's a 40 gigahertz plus signal generator with extensive trigger options and everything. One word of advice: the software comes in English, and there are, as far as I can see, no other languages available. And that extends also to the regional settings you use on your PC. So if you are living in a country where the decimal separator is a comma, you run into trouble in some of the input fields because it expects a dot as decimal separator. But yeah, that's it. Till next time, bye.